how did it come to your career as an electrical engineer, then to further studies in biomedical engineering, and from there to the idea of further exploring the element water and its different states of aggregation?
Well, so I studied electrical engineering, and there seemed an opportunity at the University of Pennsylvania for studying biomedical engineering. At the time, it was a new discipline. Nobody had ever heard of bioengineering, of combining engineering with biology. Now it's mainstream, but it wasn't then. And to tell the truth, at the time, I had a girlfriend when I was growing up and going to school and studying electrical engineering. And I think my mother was not too keen on the girlfriend. And one way to break the relationship was to send me to Philadelphia from New York, and that would do it. And I guess it worked. So I went to study. And what a blessing it was, and what a wonderful opening to a career. So I started my career studying muscles, and including heart muscle. And it was actually a computer modeling. Computers were just becoming in vogue, so to speak, at the time. And I built a computer model of the cardiovascular system. And so that was my start. I got a job at the University of Washington, where I am right now, still to this day. That was more than 50 years ago. I can't believe it. And we were studying muscles. We not just the heart muscle, but all kinds of muscles. And it came to me. I was influenced by a Japanese colleague who has since passed. His name is Tato Iwazumi, and his influence was profound. He said to me, "Well, just because the theory of muscle contraction is put forth by a famous Nobel laureate, Sir Andrew Huxley, it doesn't mean it's correct." And for me, that was a shocking revelation, because how could it be that a distinguished Nobel laureate could put forth a theory and that there might be something wrong with the theory? You know, it was an education for me to hear that. And he really convinced me. And so that launched my career. And the career was, to some extent, challenging the prevailing view of muscle contraction, because every experiment that we did, the results of the experiment disagreed with the predictions of the theory. We achieved nothing, I think, except raising a bit of concern about the theory, but the theory persists today in every textbook, the same theory, and the theory is inadequate. It simply doesn't work. And I'm sorry for being so dogmatic, but we spent 2 or 3 decades doing experiments, and we could find no fit with the prevailing theory. In the interim, I was exposed to some ideas about water, and I was introduced to a symposium by a Hungarian guy who came to work in my laboratory. So even while we're sitting in the car driving from the airport, he said to me, "Jerry," he said, "there's a really important symposium that's occurring in Hungary, and you should go there, because the symposium deals with, it was to honor the work of a biophysicist who had recently passed." And he said there are 2 subjects to be studied there, or to be discussed. One of them is water, and the other one is muscle contraction, especially heart muscle. And I was invited to speak about muscle, and I did. But the more interesting phenomenon for me was to meet Gilbert Ling, who had written by that time 4 or 5 books on water inside the cell. I met him, and I met some people who had evidence to support his point of view. And I was really taken aback by the evidence that was presented, and also by Gilbert Ling's ideas. And Gilbert was a guy who was chosen among many scholars in China as in the first cohort of people to study in the US. There were three of them, and they all thought that Gilbert was the smartest of the three. He was the biologist. And the physicist guy went on to win a Nobel Prize and became famous, not just because of his Nobel Prize, but because when he was approaching 90 years old, he married his translator, who was something like 30 years old. And so he became very famous throughout China, not so much for his Nobel Prize, but for his wife. And there were rumors that she was pregnant. I don't know if that's true or not. Anyway, but Gilbert was the guy, and Gilbert had mounds of evidence that suggested that the water inside the cell was not like water in this cup that you drink, but that the molecules were ordered. They were lined up like soldiers at attention.
Okay.
And he had a lot of evidence to support this view. And I was overwhelmed by it. I thought, this is so exciting. This is so important, because if it's really true that the water inside the cells was ordered in some way, everything changed. Everything about biology would change because of that. And so I came back to Seattle, where I live, and I took one of his books and I gave it to some of my students, postdocs, and they read through and they came back to me, and their verdict was, well, guilty, not guilty, but their verdict was that this was amazing. If this guy is right, everybody else is wrong. And so that reinforced my view that Gilbert Ling and his idea of water molecules being organized, lined up, had so much merit. And that's the reason why I wrote that book that you mentioned, Cells, Gels, and the Engines of Life. I wanted in that book to promote Gilbert Ling's ideas, or not so much to promote, partly to promote, but partly to make clear his ideas. So Gilbert, bless his heart, he passed a few months ago, almost reaching his 100th birthday, and his writing was not so clear, and it took a lot to go through any one of his books and try to really understand deeply what he was talking about. So my goal was to make it clear. So I started writing the book, and I started discussing Gilbert's ideas and trying to clarify them for a public of people who, were not necessarily so well versed in the intricacies of physical chemistry. But I went on from there to suggest something more than what Gilbert had suggested, and that the water was not only ordered, but it played a central role in everything that the cell did, that the transition from ordered water to ordinary water and then back again was an initiator of so many of the activities of various cells. And Gilbert was not so happy about that, because it appeared to him that I was kind of presuming influence or power in the field, and we had some difficulty. And I tried really hard to restore our friendship, and I finally did succeed, and I was very, very happy about that. So anyway, we changed course in the laboratory from a laboratory that was deeply involved in studying the molecular mechanism of muscle contraction, including heart muscle, to water. And the two are actually linked to one another, because, in order for muscles to contract, the water is actually central. And the transition of water from this some kind of structured water, which I have a lot more to say about how it's structured, a bit different from what Gilbert Ling has been suggesting, that this transition from the ordered water to ordinary water was a trigger for the contraction of muscles. So there is a relationship, but the focus shifted to water, which is, of course, of consuming importance to everybody. I'm sorry for this long speech.
No. It's very interesting, and it's bringing a lot of information about that. But I think a lot of people have no knowledge about the information of water, or this what is the force of water and what's the different from this water, informed water or not informed water, what's a normal water and what is the different to a water in the cell, and the information like that. I think it is really, really interesting to bring this information out to our audience.
Okay, well, yeah, I guess that's a question for me that you want me to respond to about information. Yeah. So yes, information. Most people have a sense that it's impossible for water to store information.
Yeah.
And that was the downfall, excuse me, of Jacques Benveniste, famous French scientist who claimed that water had memory, or it could store information. And I think part of the reason that he got into trouble was maybe for using the word memory, because people couldn't imagine that liquid water, something like this, could store information, because after all, the molecules are randomly disposed and they're bouncing around at a gazillion times per second. And how possibly could that kind of water store information? It's inconceivable. So of course, he ran into a lot of trouble and a lot of resistance. And I want to mention also Masaru Emoto, the late Masaru Emoto, died 5 years ago. And I have something to say about that too, because what we found is a kind of structure that actually has the capacity, it doesn't prove anything, but it has the capacity to store information. And that's the ordered water that I began talking about by Gilbert Ling. But we found that the structure, in fact, is different from what Gilbert suggested. Gilbert suggested that the water molecules remain as they are, but just line up basically to form an ordered array. And we found that was not the case. And one of the pieces of evidence of many was that the ordered water had a negative charge typically, and water molecules have zero charge. So you can line up water molecules, from here to the moon, and you'll never get a negative charge. So we knew something was wrong, and we did many studies, and we found that the real structure, at least as far as we can understand it, is a sheet-like structure where the water meets some material, and as the water meets the surface of that material, if the surface has certain character, that is, it's hydrophilic, water-loving surface, the water molecules would transform from molecules into a sheet or a stack of sheets, beginning at that surface and stacking from there outward. And each sheet was like a honeycomb, hexagonal sheet, and they would, one sheet would provide the basis for the next sheet and the next sheet and so on. And we found that experimentally you could have many, many, many sheets, up to, for example, in the right circumstances, up to 1 million. It's certainly not in the cell because there's not enough space for that, but a lot of that. And if you think about information, the first thought that one has is, well, information, that could be stored in a thumb drive like this. And so what's inside of here? And what's inside of here basically is silicon atoms that are lined up in 3 dimensions, in a regular array. And the critical feature of this, and my laptop, is that each one of the silicon atoms can occupy one of 2 states, either of 2 states, which we label with 0 or 1. And so now, if you take this as a model or an example, and go back to the array of water, which we call 4th phase water or EZ water, standing for exclusion zone, should be EZ in Germany, EZ water. What does it have any of these characteristics? Are the atoms lined up? Yes, they are. And do the atoms, could they possibly, either oxygen or hydrogen, could they occupy 2 states, just like the computer memory? And the answer to the second, I already answered the first question, and the answer to the second question is not only 2 states, but 5 states. So we take the one for oxygen, the one that we know about is the -2 state. We call that valence, but oxygen actually has 5 different oxidation states: -2, the familiar one, -1, 0, +1, and +2.
Okay.
See? Incredible. So it means that just like the computer memory, at least theoretically, the easy water or fourth phase water has the capacity to store information.
Mhm.
Now, nobody's figured out exactly how this works. We're working on it. But in theory, the capacity exists. So I go back to water memory and information. The water that's in your body, which is mostly easy water, fourth phase water, has the capacity to store information. And similarly, a container of water also has the capacity, or a petri dish full of water, as is the experiments of Masaru Emoto and those who follow in his footsteps. In theory, the capacity exists. So this is really exciting because there's so much work that has been done by Emoto and group, and of course by Jacques Venvanist and many, many people now who come to our water conference each year. We have, typically there will be 2 or 3 or 4 presentations on information or memory of water. So this is a field where I think this is the frontier of science, and understanding how this happens exactly. And we have people who come regularly to our conference, and will be there at the next conference, which will be in April in Bad Soden near Frankfurt. And that's Luc Montagnier, who won the Nobel Prize in medicine for discovering HIV. He's now studying water and the memory of water and the critical importance of memory and information of water. So this is really, really important in science, in nature, and in everyday life. I think I should stop because you have other questions.
Yeah, but it's important to know that in our body too, because we have 70% in our body like water, and yes,
yeah, it's right. Not just 70%, but something that people get confused about. That is the fraction of molecules in our body that are water molecules. And if you do the arithmetic, 70% is by volume, right? If you line up all the molecules in the body and start counting, you'll find that just going back a step, to fill that volume, because water molecules are so small, you need a lot of them to fill that 2/3 volume. And if you do the arithmetic, it turns out that if you were to line up all the molecules in your body and count them, more than 99 out of 100 would be water molecules. So, and modern biology really discounts it. Modern biology presumes that those 99 out of 100 molecules are merely the background carriers of the molecules, important molecules of life, like proteins and nucleic acids. They don't do anything. They're just like water sitting in a bathtub. You jump in the bath and take your bath, and they just surround you as they surround proteins and such. So it's not very important. All of biology, modern biology, is based on that concept, and I believe it's wrong.
Okay.
Water is critical.
If you allow me that I go to the next question, because it's interesting. I think, again, because you said the states of aggregation are changed by energy such as hot and cold. Now you researched that ultraviolet light as a form of energy also influenced the state of water. What exactly happens, and what are the consequences you deduct from it?
Okay, thank you. Yeah, so first of all, there's a bit of confusion that many people have between ultraviolet light and infrared light. So you have the electromagnetic spectrum that goes from very long wave or very short wavelength to very long wavelength, and it's a very wide spectrum. And the visible light is a very narrow portion of that spectrum, with red at the long end and violet at the short end of wavelength. And if you go just a little bit shorter, you get to ultraviolet. And if you go a little bit longer, you get to infrared. So infrared turns out to be the one that actually expands this fourth phase water. If you start with some fourth phase water and you illuminate with infrared light, the exclusion zone or fourth phase grows in size. And we've seen it grow up to 10 times the amount by exposure to infrared light. Now, ultraviolet light, on the other hand, has got to do something. And we started studying it, but we haven't reached a point of conclusion. And so far, the preliminary, highly preliminary results show that what the ultraviolet light does is to increase the negative charge of the fourth phase of water. And that is not conclusive because we haven't done the proper controls. And we're starting to work on that once again. So we're not really sure, but you know, we absorb some of that, so much of that from the sun, and the sun gives us energy, and we can imagine that it could be the visible light from the sun, but it could also be the ultraviolet light, which may confer additional charge to this water that's in our cells, and therefore additional energy. So therefore the sun gives us energy. And the other way the sun could give us rather direct energy is through the infrared that comes from the sun. More than 50% of the sun's energy is in the infrared. And it's all around us. You basically can't get rid of it. And when we absorb this infrared energy, what it does is to build the fourth phase water that is in our cells. And this water, it's necessary for full function, for the fourth phase water to fill our cells, basically. And if we don't have enough of it, our cells can't function properly. The cells are dysfunctional, or maybe even beyond dysfunctional, they're pathological. And so when we absorb infrared energy, it builds the easy water, fourth phase water, and restores our complement of this water back to normal. And so we feel better. And that may be one reason why we step out into the sunlight. It's been 5 days of rain. You know, we get rain in the Pacific Northwest in the wintertime quite often. And people feel good when finally the sun breaks through those clouds. And especially so when you subject yourself to a sauna. I don't know how popular it is in Germany or Switzerland, but I you know, in Scandinavia, of course, it's really popular, and also in Russia, where they refer to it as banya. But when you walk into a sauna, it's heat is the central agent, and heat is essentially the same as infrared energy. And so what you're doing is exposing your body to infrared energy, and the infrared energy is then absorbed by the body, and that builds easy water, fourth phase water, and we feel better. And I think this is a possible explanation as to why the sauna is as effective as it is.
Wow, good information.
Well, it's useful information. I've experienced that myself. I've experienced it. There was one incident. I was in Finland, and I went to a conference, and I gave a talk. And that evening was some sort of party, and they bussed us to some remote location, and we had some singing and whatever. And I was really tired because it was the end of a very long day for me, jet lagged. All I wanted to do was to go to sleep. So when somebody came up to the microphone and said, and was about to announce something, I was sure that he was announcing that the buses are ready for loading up and we'll go back to the hotels and everybody could go to sleep. He said, the sauna is now open. And so I felt so disappointed because I really wanted to go to sleep. So I thought, okay, I'll go to the sauna. And in 20 minutes, and following a shower, I was back in the main room with all the other people. It felt like I had just had 8 hours of sleep, and I was
Wow.
ready for the next day. That's
Completely
how
fresh.
amazing, amazing. And at the time, I wasn't really thinking of how it works, but now I think this is how it might work. And so it's truly amazing. I think the Scandinavians are smarter than the rest of us, and the Russians in enjoying the sauna on a regular basis.
Yes, there's a lot of things from the information, which the answer for this next question is, I think, because the next question was, how do you interpret this knowledge in relation to body cells? Are there positive or negative influences when both water and cells play crucial roles? And you answered that, I think.
Okay, then we go to the next question.
Yes,
Okay.
I think. And to what extent is a whole interaction related to a healthy or sick cell, e.g. a cancer cell?
Yeah, okay. So let me speak about cancer cells, but I need a couple of minutes to give a bit of background. So the first bit of background has to do, and if I get off track, please put me back on track because I have a habit of doing that. Yeah. So if you stick an electrode into a cell, you measure a negative electrical potential. This is well known for 70 years. And by the way, it was Gilbert Ling, who I mentioned, who invented this special glass microelectrode that allows you to measure the electrical potential inside of a cell. It's always negative. And typically in healthy people, or certainly healthy animals, humans is more difficult to make measurements, but it's probably similar. It's minus 70 or 80 or so millivolts negative compared to the outside of the cell. And the question is why? Why do you have negative electrical potential? And there are theories that you'll find in the textbooks that have to do with the membrane and the membrane pumps and channels. And a lot of people are aware of this, and I think it's not correct. I think the correct answer, and I can give reasons why, but I don't want to digress too much. It's the water inside the cell. The easy water that fills the cell has got negative charge, and so if you fill a bag with something that has a lot of negative charge, and you stick an electrode in, you'll measure negative electrical potential. And that's why in gels, which have no membrane and no pumps and no channels, you get the same result. It's, again, minus 100 millivolts or something like this. They don't need the membrane because it's in the water. It's not in the membrane pumps and channels. Okay, so a healthy cell that's full of easy water, the electrical potential will be 70, 80, 90 millivolts. In a cell that is lacking this water, the electrical potential would be less negative, maybe minus 50, minus 40. In cancer cells, it was reported many years ago, because people at that time were really interested in electrical potential, now less so, because they think everything is answered. But instead of being minus 60, 70, 80 millivolts, it's minus 10 or minus 15 millivolts in cancer cells. So what that means, according to our interpretation, is there's less easy water. So cancer cells don't have as much easy water as you have in your cells, and this could be really important correlate of what is going on in cancer cells, because the cancer cells can't behave in a normal way, and they just go on dividing. And the reason they go on dividing is that the stable state, non-mitosis, non-division, most of the time, it can't go into this stable state because it's lacking the structured or easy water that's necessary to hold it in that state. So it goes crazy and keeps dividing. And so I don't know that this is necessarily the basis underlying cancer, but I think it's a very important concept that needs to be looked at. Not many people are looking at that. Okay. So I hope that answers your question.
Yeah, really well. Thank you so much for that. And though the next one is then, can water influence our immune system? positively and possibly even protect us from infections, degenerative processes, and diseases?
I'm not an expert in the immune system, but you know, like everything else in the body, certain cells are responsible, and and I think it's a generality that all of these cells contain easy water, or practically filled with easy water, and if they don't have enough easy water, they're not going to be functioning in a normal way, and that's the same for the immune system. Because it also is based on cells, and if the cells that are involved in the immune system are not functioning properly, then the immune system is not functioning properly. So I guess I would like to leave it at that, because I don't claim any expertise. It's just that there's a generality that all cells, in order to function properly, need to have this water in the cell. So yeah, let me stop there, because you've got other questions, and I know our time is
I'm searching
limited.
at the moment in my dictionary about a word. I want to comment this question. Water was already a topic of interest by Lucas Cranach painting The Fountain of Youth. You know this picture?
If I saw it, I'd probably know it, but I'm not sure.
Okay, because you see that on this picture, that all the elderly people standing on a pool, on a swimming pool like that, yeah, and this picture was painted on 1578 or like, or say 1571, and you see the elderly people go in the pool in this water, and on the other side coming up out, and all the guys was complete free from pain and was refreshed and looks like younger, and they go then in a special tent. In this tent. And I think it is the old thing what the people are looking for. Where is here the fountain of youth? I think.
Well, so a few comments on that. It reminds me of the Japanese mud baths. You know, you sit in the mud bath. I haven't done it, but I'm sure there are people here who have done it, and you feel good afterward. And what you're doing is connecting yourself to the earth through a conducting medium, right? And the same thing could be happening in the water. You see, if the water has some conductivity to it, then it's connected to the earth. Why should that improve health? And you know, people have been studying the idea of earthing or grounding for many years now, and there's a lot of literature on it. And it seems that if you connect yourself to the earth, either through sticking an iron rod in the earth and connecting yourself electrically to it, or the ground plug and the receptacle in the wall, or the mud bath, or walking barefoot on the beach, they're all connecting you to the earth. And why should that result in improved health is the question. And there are lots of people speculating on various reasons, and I have my own speculation. And that is, you're connecting yourself to negative charge. So in the US, almost nobody knows that the earth has a net negative charge. And when I started studying electrical engineering, no professor ever told me that the earth has negative charge. We all assumed that the earth was neutral. I mean, that's the natural assumption. However, the evidence, and there's a lot of evidence, is that the earth has negative charge. So what you're doing is you're connecting your body, either in the mud baths or any of the other methods, to a practically infinite source of negative charge. So if your body now, if your cells don't have enough negative charge, don't have enough easy water, you're not feeling particularly well, you connect yourself to this infinite negative charge, and the negative charge seeps into your body. And we have experimental evidence that if you add negative charge to the water turns into easy water. See, so it means that when we connect ourselves to this negative charge, it builds easy, or fourth phase water in our cells, and we become healthier again. And I think that's the reason why walking, as the painter depicted, uh, uh, connecting ourselves with water. It could be ocean water, full of salt and full of high conductivity, connecting yourself to the earth, or walking barefoot on the beach, or any of those expedients. We feel healthier, we feel more robust. And I think the reason is the simple reason that we're connecting our bodies to negative charge, builds easy water, and we feel better.
Okay, thank you for that.
Okay.
Yeah, so we'll go further to the next one. How does water in plants and in food, such as fruit and vegetables, behave in relation to energetic states and a possible influence on our cells?
Well, that's a pretty broad question. And let me direct the question to the word influence. And speaking of influence, so if we eat or drink whatever what's in the plant's leaves. So a lot of people do juicing. You take the green leaves from the plant and you squash them to squeeze out the juice, and you drink it. And the reports that I've heard from the health practitioners who prescribe it for their patients is that it's uniformly effective. Patients will be suffering from some sort of pathology or malady, and they start drinking this juice, and they come back a few months later, and whatever it is that was bothering them, the situation has improved a lot, and they've also lost weight. Everybody wants to lose weight, it seems, but it seems to work. And so how or why is it working? And I think the reason it works is that what are you doing when you take the leaves and you squeeze them to squeeze out the juice? You're squeezing out the water from inside the cells of the plants. And the cells of the plants are full of easy or structured water. These leaves are fresh and new. They've just come that season. They're not pathological, and you squeeze out the water, and then you drink it. What you're drinking is fourth phase or easy water. And if you drink that water, then it's an easy pathway to building the easy water inside your cells. And you're progressively, gradually restored toward normality. So I think that, that's what we're talking about in terms of the plants, but there's more. And that is the rising of water inside the plants through the xylem, and this will bring us to the heart if you ask me the right questions, and we have time. So what we have in the U.S. we have tall redwood trees that are 100 meters tall, and the question has never been properly answered. And how does the water get to the top of the trees? Because it's a long column of water that's very heavy, and we think we've identified the mechanism, and that is these conduits are basically tubes, and we've found evidence that you could get flow in tubes, just like capillaries, for example. You can get flow in tubes based on the energy that comes in from outside, the infrared energy that builds the easy layers just inside those tubes, that separates charge and as a result promotes flow. So we have several papers on it, and it's in my later book called The Fourth Phase of Water, which I think has become rather popular with a German translation.
And it's possible to find this on YouTube. I think there is a small video about this works, how it flows the water about this tube.
Yeah, it flows, and for us this is exciting. And I say we discovered this, but actually it was an undergraduate student, young student, 18 years old, 19 years old, studying at the university and working in our lab, and he was studying tubes made of a material called naphion, which is a very hydrophilic material, and we've used it a lot, and it builds exclusion zones very nicely, and we we found out that this comes in tubes, just like straws. And he was studying in the laboratory, and he was curious about phenomena, and he found that that if you put one of these tubes in water, that there was flow through the tube, and the flow would not stop; it would just keep going. Amazing, yeah. So one day, I won't forget this incident. I was sitting in my office with a visitor. I think, I don't remember who the visitor was, but I think he was maybe an important visitor. And a student comes barging in. Usually the students are a bit more polite and thoughtful. They'll either knock at the door or say, do you have a moment, or something like this. But he came barging in saying, I have something I've got to tell you about. And I thought, well, I hope this is interesting, because you just interrupted the conversation. He said, I found the water flowing through the tube without stopping. And I thought, if this is correct, it's not only interesting, but it's profound, because where is the force that's driving the water through the tube? Usually you need pressure, just like in the cardiovascular system. And it wasn't there. So I said, if this student is correct, I was thinking, this demonstrates that the idea that water absorbs energy, infrared energy, for example, from the environment, and supplies energy to the water, that would not necessarily prove it, but give strong evidence in favor of that. So we studied this, we wrote a few papers, and we were excited. And that leads me to the next point about the heart. May I go into that? Yeah, because I think this is the subject of the conference, and people are interested. So I'll give you first the summary, and then I'll tell you. We found that in addition to the heart pumping the blood, the capillaries also pump the blood. The capillaries move the blood along. Even if the heart is not contracting, it can do that. And so how did we find out? Well, it started with a trip to Russia to visit my colleague, friend, Vladimir Vyakov at Moscow University. And he was quick to introduce me to the guy in another laboratory who came, and Vladimir translated. And the guy was telling me, he starts by telling me there's a big problem in the cardiovascular system. And, my initial response, I have to admit, was slightly arrogant, because I studied the cardiovascular system as a graduate student, and I modeled it, pressures and flows, computer modeling, primitive computers, but computer modeling. And I thought, I had it all worked out, and I could understand all the pressures and flows. And he had me convinced otherwise within 5 minutes. So what's his argument? His argument is very simple. He said that in healthy young adults, the size of the diameter of the capillary is 3 or 4 micrometers, but the red blood cells that have to pass through are twice the size. They're 6 or 7 micrometers. So something, it looks as though maybe nature made a mistake. Mother Nature screwed up, but Mother Nature doesn't screw up. There's a method to her madness. So he said, what happens is that somehow the capillaries have to squeeze their way through. The red blood cells have to squeeze their way through. And you can see videos, and I show them, showing that the red blood cells, they're supposed to be more or less planar, like a coin, but they actually squeeze like this. And in order to squeeze them, so that they can actually go through, requires energy. And he calculated how much energy is required to do it. And he calculated that if the heart is fully responsible for doing this, it would have to generate enormous pressure, a pressure like 1 million times the pressure that it ordinarily generates. That's high blood pressure, million times. So he said, there's got to be a second source of energy that propels the blood. And he was thinking about, he had 5 or 6 different ideas. And meanwhile, I'm thinking, we just saw in our laboratory that we take a tube that's just like a capillary, right? And put it in water, and the water flows through. So maybe the blood flows through. in a similar way. And so we did experiments actually carried out by my student, Zheng Li. And he tested this in a mammalian preparation, a chick embryo. And the embryo is 3 days old. It's before various feedback systems have developed, before the neurological feedback or hormonal feedback is very well. So it's just basically, principally, a growing cardiovascular system. And the first thing he did was stop the heart from beating by adding potassium chloride the standard way. And, you know, the chick embryo complied, by the heart stopped. And he found that the flow, which he could measure using a microscope, special microscope, kept going. It was much slower, but it kept going. No heartbeat, the flow keeps going, you see. And he found out since then that his finding was not unique, that over the past 100 years, there have been some half dozen papers written on the same subject, each one describing a different system, a different physiological system, but the same result, that if you stop the heart, the flow doesn't disappear. So something else is involved. And then finally, he tested the signature feature of this phenomenon of flow in tubes without a pressure driving it, and that is infrared energy. So the signature feature, you add infrared energy, you get faster flow, more flow. He tried it and it worked. He found that he would get, by exposing this circulation to infrared energy, he could speed up the flow by 3 times and then remove the infrared, and it went back to its normal. So we're pretty confident that this is operative in the cardiovascular system. We're working on a manuscript now, that in your cardiovascular system and in my cardiovascular system, it's not just the heart that is pumping the blood, but also it's the capillaries themselves that are propelling flow through the capillaries. And we don't know, in a physiologically functioning heart, we don't know which one is more important than the other. That's yet to be determined. But this is significant. And of course, it leads to various possible therapies that people hadn't thought about. So since you got other questions, I'll stop that one here.
Yeah, but it's very interesting, I think, for all these people who have cardiovascular problems with health and so on. There's a lot of people in our country here who have these problems via sugar and so yeah, it's the fat on all this stuff. What's happened to people here?
Yeah. And, it's not just there, but it's here too in our country, really seriously.
So I want to jump to Masaru Emoto, because he showed in the research and photographs of frozen water crystals and influence of different energies, how water change in its aggregate state as a frozen crystal. He believed that water can absorb and store the influences of thoughts and feelings. You had a more intensive exchange with Masaru Emoto. Do you see a connection between his research results and your own research? What would this be or could be?
Yeah, well, his work has had a profound influence, and not only his work, but the work of the people who are following in this. That would be Akiko Stein and Michiko Hayashi and Yasu Nemoto and others. We've had lots of exchange, and I think the answer is yes. So I actually never had the pleasure of meeting Masaru Emoto. We invited him to speak at our annual water conference, and 2 times, and each time he declined because he was ill. But I found out from some intermediary that he was going to come to the Northwest, where I live and work, and I invited him for dinner at my home. My late wife and I invited him, and yes, he was coming, but he never showed up. He never came, and he had a good excuse. He passed, unfortunately. He died a few weeks before coming. So we were really tremendously looking forward to meeting him, because we actually appeared together on an interview show. I was the scientist and he was the spiritualist, and the idea was to bring the two together into a meeting. And the work that he and his disciples, if you will, have done, have had a real influence, because we're approaching the issue scientifically. Is there a basis for understanding how an emotion or an intent can influence the water? And he provided evidence. Some scientists are skeptical because of the way the images were cherry-picked, but there's been a turn in the group to a more scientific approach to this, and I believe there's something to this. And scientifically, we've provided what I think is a basis for understanding how that influence could possibly occur. In fact, it's inspired us to begin a series of experiments, which we're actually beginning right now with healers. Question is, if we have a healer who is sitting next to a container of water, does the healer's intention, positive intention to the water, does that change the physical properties of the water? And we don't know the answer. We think probably, possibly yes, but we're just starting, and we have 5 different methods in our laboratory, physical methods, objective physical methods that could be accepted by any scientist to study and determine whether indeed the water is changed by intent or influence. So this is exciting. We're just beginning those experiments in the next weeks.
Okay. Wow, it's very interesting, and I will look for what's happened there in the future.
We do too.
Yeah. I have 2 questions more. Is this okay? But I know time is now 1 hour.
Sure, it's okay. It's my privilege.
Oh, it's nice too. Thank you so much for that. It's a gift what you give us now. Thank you for that. If you look back on your research and results of the last years regarding water, what are the most valuable findings for you, and how might this have influenced or changed your own behavior and life?
Well, more and more, I seem to be turning my attention to problems of the world and to healing of these problems. And this was not the case some years ago. I was intent as a scientist in a box, doing my own thing, trying to find out what I could find out about nature. But right now, I'm really moved by the problems that we face, and I feel a compulsion to devote a good portion of my life to helping to solve these problems. And water is at the center of so many of these problems. So we've developed some practical outcomes which can benefit the world. And let me just run through. We started a company, although the company, well, is in transition right now. Let me put it at that. And the idea was to develop some of these applications to solve some of the problems of the world. I'll just briefly mention 3 the first is getting energy from water and sunlight. So, photocells have been developed over many years, and one of the problems with these solar cells is that they deplete the resources from the earth. And the system that we developed, it works demonstrably. We can get energy simply by taking water next to a hydrophilic surface and exposing it to light. We've demonstrated it, but like most laboratory demonstrations, you have to cross a valley. It's called, I don't know if there's a same equivalent in the German language, but it's crossing the valley of death to get from a laboratory demonstration to something that is usable for the world. And we started to do that because getting electricity in a natural way from light and water can really change the pattern of the world's existence. So that's one. Second one is filtration. So we all know that the waters of the earth are filled with spent pharmaceuticals, with plastics, and it's just awful, and we need to do something about it. So we've developed a filter that, once again, we're trying to develop for use, widespread use. And the filter, we call it filterless filter, because it doesn't operate on the same principles as a usual filter is, where you have a physical filter and it gets dirty and you have to replace it or clean it or whatever, and that makes for real complications. And ours is essentially, you take this easy water, you build the easy water and you collect it, and we call it easy because it's exclusion zone water. It excludes virtually everything. It excludes pharmaceuticals, it excludes the plastics, you name it. And so we developed a system whereby we collect this water, this easy water, and that water is, I wouldn't say pure, because first of all, it doesn't necessarily exclude everything. We're not absolutely sure, but excludes most of the stuff that you want excluded. And it's also, in fact, easy water. And easy water is good for health. You see, so it does double duty. And we're trying to, again, to bring this from a laboratory demonstration, which works very nicely, to something in which the throughput is high enough that it could be useful. And we spent quite a bit of time working that. So that's two that we're working on in the service of humanity. And a third one is, for me, one of the even more exciting, this filtration, we think will separate salt as well. We're working on that. We have been working on that. And the idea is that we could take ocean water and create drinking water. And of course, you know that that's possible. It's done all the time with reverse osmosis. But the cost of running those machines is huge. And, you know, in the Middle East, you can afford it, maybe, because there's lots of oil available, at least for the next few decades, to run those reverse osmosis machines. But, you know, we're going to run out of that source of energy. We need something that doesn't depend on that kind of energy. So in our system, it depends on light, the energy from light. And we have no physical filters to replace. So if we can get this to work, this is a big if, we don't have it working yet, although some experiments are promising, then it will create a system whereby without energy, or with only the energy from the sun, we can separate the salt from the water and have pure drinking water, which is mostly easy water. So we're really excited about it. And so I guess your question is, how has that changed the trajectory of my career? And I've always been interested in the pure science and trying to figure out how things work. But some part of me now is oriented increasingly toward helping to solve the problems of the world, which some of which center on water.
Very interesting. Wow.
Well, thank you.
The right step to the next moon.
Well, yeah.
So I come to my last question, but I have hundreds of questions now, more, but I don't tell you that. But I have the last one. Is there any special advice that you would like to share with our viewers, and any learnings that could be implemented into our everyday lives?
You ask hard questions. Well, yeah, I guess I do, and I guess it has to do with health, and I guess it has to do with maybe alternative health, because you know, I see what's happening. We're getting sicker and sicker, and why is it that we're getting sicker and sicker? And I'm convinced that the environment has a lot to do with it. And so, you know, you get sick and you go see a physician, and you're hopeful that the physician can cure your ills. but at least in this country, the physicians are not well equipped to understand the influence of our environment in our sicknesses, and so I've come to realize that, and they're bound by their education. You know, they're bound by well, we know if you have symptoms A, B, and C, you should get drug X, Y, and Z, and that will hopefully take care of it. But sometimes it works, sometimes it doesn't work, and the side effects are so well known. And I've come to realize that many of the people, healthcare people, are beginning increasingly to study alternative kinds of approaches, and so I guess the way my life is changed, and I would advocate is to people is to go beyond so-called allopathic or conventional medicine and get some input from people who have other ideas. I'm not suggesting giving up allopathic medicine. They're very good at some things like emergency medicine, but in terms of the chronic diseases, there's a lot to be learned from people who think in different ways. And so that's what I would advocate. And if you allow me another couple of minutes to give a plug for an organization that's trying to accomplish something like that, it's called the Institute for Venture Science. And it's an organization that I helped to create over the past decade or so. And the idea is to provide resources, wherewithal, money for scientists and healthcare people to pursue ideas that are out of the mainstream. See, it's really difficult now to do that because if you were, for example, to propose to one of the European foundations that you wanted to study round Earth, let's say, and all of your colleagues knew that the Earth was flat, but you're an iconoclast and you have the idea that the Earth is really round, and you come to this organization and you say, hey, all of you guys think the Earth is flat, but I've seen satellite photos, and they show, strangely, that the Earth looks round, not flat. And you decided further to pursue this idea by getting into a plane and going around the world. And you looked out the window and you're looking at the Earth and you're looking for the edge of the flat Earth. You can get back to where you started. And so the Earth must be a cube of some sort. And therefore you're looking, but you can't find the flat, the edge of these flat surfaces coming together. So you go to the organization and you say, hey, I want to study the shape of the Earth, but I can't do it without money. Please give me €500,000 or something like that. So they receive your grant application, and they think, oh, this is pretty interesting. It's profound. If this guy is right, if Tino has a really good idea, then it's very important. And we better get the best possible reviewers to look at his application to make sure that he's not a crackpot, that he's got something. So they pick the experts to review your application. Who are the experts? The people who are most famous for their belief in flat Earth, right? Because so you're actually challenging the people who are reviewing your application, and it's obvious what the result is going to be. You'll never get your money, and scientists know that. If you were to ask people, suppose you had a radical idea, do you think you could get funding for it? And the universal answer is no. I keep that to myself. I don't pursue it. I have some interesting ideas, but I don't want to get a reputation of being radical because I won't get any money. And if I don't get money, I won't get anywhere. So we have an organization that's designed to give money to people like you who are pursuing these round Earth ideas. But it's not just giving you the money, because if let's say our organization is to give you money to study round Earth, your round Earth idea, you won't gain a lot of traction. Why is that? Because the flat Earth people are going to say, oh, Tino, he's a crackpot. Don't pay any attention to him. And what's your defense? Are you going to raise your flag and say, oh no, I'm not a crackpot? It won't work, right? You're a crackpot. You're defined as a crackpot, and they won't change their opinion. And nobody will follow your work because, oh, that's the work of a crackpot, right? So our design circumvents that. How does it do it?
Yeah.
It circumvents it by, if we fund you to pursue your round Earth idea, we're going to look for another 10 laboratories around the world who share your vision that the Earth is round. And they may be using different methodologies. And then they come to the annual conference of the shape of the Earth. And suddenly you've got 10 groups that are reporting that the Earth is round, each one using a different technology, a different method to assess their results. And the world can't ignore that anymore. They can't just say, well, one of those people, Tino, he's a crackpot, but what about all the others? Are they also crackpots? And by the way, how do they get all that money from this organization if they're really crackpots? See, so this is our method, and we've identified 5 groups from more than 200 pre-proposals who we think, if they could get the money and pursue their work, is going to change the world. So we're looking for funding, and if anybody has done well in their career and want to give back in some way that can actually have a profound influence on the world, please don't hesitate to contact me. This is the Institute for Venture Science. URL is IV as in intravenous, but ivscience.org, O-R-G, and it will get to me. So, okay, anyway, that's my extended answer to your question.
Make an underline on this and you can send it out.
Okay, a link, yeah, sure.
It is important, but it's remember me on this Galileo story.
Sure, but it hasn't changed.
No, it is.
The details are changed, but if you have a radical idea, it's an uphill battle to really change the world.
If it's not mainstream, you are out of order.
You are out of order. That's right. Indeed.
It's bad stuff in the whole world, and I know that.
Yeah.
Okay.
Well. Yeah.
So I'm really thankful for that talk, what you have or what we have together. Thank you so much for your time, Professor Pollack. This was really, really interesting, and I hope we have the position in the future that we can talk together by a lunch or by a dinner.
Absolutely, it would be my great pleasure. But if we do it, don't come to Seattle in the wintertime because it rains.
Okay, that's nearly like the same here in Switzerland. At the moment, we have snowing of 800 meters like that. And
oh, wow.
Now 5 degrees at the moment.
Oh, yeah, but it's beautiful.
Yeah, but it's fine. It's winter time. So we have time to make some things what we don't do that in the summer.
Okay, well, thank you. It's my pleasure. And I really do hope that we have an opportunity to meet in person. Thank you for the opportunity.
Thank you so much. Take care and have a really good time for the future. And I wish you a big force to go further with your ideas and all these things.
Oh, thank you so much. And thanks to Akiko for connecting us.
Yeah, thank you so much, Akiko. For that job was really great. Thank you, everyone, that you have time.
Take care. Bye.
Bye.